Curious Facts in Magnetism from Scientific American, March 29th, 1879. Recorded for the LibriVox Coffee Break Collection, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Tom Viscelli. Curious Facts in Magnetism from Scientific American, March 29th, 1879. The meeting of the New York Academy of Sciences, February 17th. The article in the March number of Harper's Magazine entitled Gary's Magnetic Motor was incidentally alluded to, and Professor C. A. Seeley made the following remarks. The article claims that Mr. Gary has made a discovery of a neutral line, or surface, at which the polarity of an induced magnet, while moving in the field of the inducing pole, is changed. The alleged discovery appears to be an exaggerated statement of some curious facts, which, although not new, are not commonly recognized. If a bar of iron be brought up end on near a magnetic pole, the bar becomes an induced magnet, but an induced magnet quite different from what our elementary treatises seem to predict. On the first scrutiny, it is a magnet without a neutral point, and only one kind of magnetism, that of the inducing pole. Moreover, the single pole is pretty evenly distributed over the whole surface, so that if iron filings be sprinkled on the bar, they will be attracted at all points and completely cover it. Now, if while the bar is covered by filings it be moved away from the inducing pole, the filings will gradually and progressively fall, beginning at the end nearest the inducing pole and continuing to some point near the middle of the bar. The filings at the remote end will generally be held permanently. When the bar is carried beyond the field of the inducing pole, it is simply a weak magnet of ordinary properties, that is, of two poles and a neutral point between them. A plausible and simple explanation of this case is that the inducing pole holds or binds the induced magnetism of opposite name, so that it has no external influence. The two magnetisms are related to each other, as are the positive and negative electricities of the Leyden jar. Let the inducing pole be north. The south of the bar will be attracted by it and bound, while the north of the bar becomes abnormally free and active. On moving the bar from the pole, the bound magnetism is released, and a part becomes residual magnetism. Now, when the residual balances the free magnetism, which is of opposite name, we are on Gary's neutral line. In a restricted sense, there is a change of polarity over the half of the bar contiguous to the inducing pole. On the other half, there is no change of pole in any sense. Experiment with a shingle nail in place of the filings a la Gary. Bring the nail to the induced bound pole, and it may be held, except at the neutral line. Now, if one will read the magazine article with such ideas as these, he will feel pretty sure that the writer of it has used words recklessly, that Gary has not made an original discovery, and that the neutral line, whatever it be, has only an imagined relation to the principle of the motor. The Gary motor, as a perpetual motion scheme, of course, is not worthy of serious notice from a society devoted to science. It has no noteworthy novelty of construction or conception. Mr. Gary is afflicted with a very old illusion of the cut-off or shielded magnetism, which is to cost less than what comes from it. His cut-off is a sheet of iron, which we know simply acts as an armature. End of Curious Facts in Magnetism from Scientific American. Recording by Tom Viscelli, Millburn, New Jersey.